Okay, Ethan. So here were the 4 questions that you had. This is starting on page 565, or excuse me, 569, number 5. The given information is that there's a soft metal that weighs 54.3 grams. They tell us it's either lithium, sodium, or potassium. And then they place it in a cylinder with a radius of 4 centimeters, and that the water is going to rise 2 centimeters. And so the part that you're trying to find here is you're trying to find the volume or the change in the level of the water. So essentially what you're going to do is you're going to find the volume of the cylinder with a radius of 4 centimeters with a height of 2 centimeters. You can pause this and take a look, but here's the work finding the volume. Density is mass over volume. You take the mass of 54.3 grams divided by the volume, and you'll get a density of approximately 0.54 grams per cubic centimeter. If you look up on the page, or if you look up on the chart on page 555, you'll find that the metal is lithium. Question number 7. It says, find the weight of the hollow steel ball, or of a hollow steel ball, given the following information. The outer diameter is 14 inches, the thickness of the ball is 2 inches, and the density of steel is 0.28 pounds per cubic inch. So strategy. What we're going to do here is we're going to find the volume of the outer layer, or what I would consider just the entire sphere, and then we're going to subtract out the inner sphere, the smaller one. So we're going to use a diameter of 14 or a radius of 7 on the first one, and then it says that it has a thickness of 2 inches, so we're going to use a diameter of 5 for the second one. So you count the volume of the outer sphere and the inner sphere, you subtract those two, you'll get a volume of 913.17 cubic inches. Density is mass over volume. If the density of that was given is 28 hundredths pounds per cubic inch, you can set up a proportion to solve for the pounds given the volume. And that weight is 255 and 69 hundredths pounds. Question number 8. Question number 8 was probably the hardest of the 4 here. It said, find the thickness of a steel ball given some information. So you know it's a hollow steel ball. You know the diameter is 14 inches. The weight is 327.36 pounds, and it still has that same density of 0.28 pounds per cubic inch. The first thing you're going to want to do is calculate the volume of the steel. So using the weight there. So pounds per cubic inch, pounds for how many cubic inches. So the volume of the steel is 1,169 and 1400 cubic inches. Once you know that, to get the volume of just the steel part of the sphere, you take the volume of the outer sphere minus the volume of the inner sphere. We know the volume of the steel. We know the radius of the outer sphere. What we don't know is we don't know the radius of the inner sphere. All right. So what we did here is we factored out the common factor of 4/3 pi. And then we started solving for r. So I divided both sides by 4/3 pi. I subtracted both sides by 7 to the 3rd power. And then I undid multiplication, or multiplying by -1 here, by dividing by -1. And then took the cubic root of 63.89, and I got approximately a radius of 4. Okay, so if we knew that the radius of the outer layer was 7, the inner layer was 4, that means it has a thickness of 3 inches. And then finally, your last question here, question number 9, it says, determine the density of the heavy metal object. Is it platinum? So they took a hexagonal prism, side lengths of 5 centimeters, and the water rises 4 centimeters. They also tell us the weight of the object was 5,457 grams. So if it's a hexagonal prism, we have a side length of 5. We'll have an apothem of 5√3/2. That I can use that information to solve for the area of the base. Area of the base times the height gives me a volume of 259.8 cubic centimeters. Density is mass divided by volume. I get a density of 21.005 grams per cubic centimeter. The density for platinum was 21.4. And I looked that up on page 55. Therefore, the object is not platinum. All right, there you go.